Astronomers have been peering into space for over 60 years in search of artificial signals, and it's been more than 10 years since they've come across the very first fast radio burst, FRB, in 2007. The second bursts of radio emission have bewildered scientists by the mystery of their true nature. And as we've just started to understand what's causing these strange signals, a recently discovered FRB has nearly brought scientists back to square one. At some point, humanity became obsessed with the possible discovery of other civilizations like ours. And now we're exploring space more than ever before with new advanced methods, and one of the main ways to find an alien civilization is to look for FRB signals. Fast radio bursts are a great example of such signs. What's more, space is full of these ultra-fast bursts of radio waves that last just for a millisecond or two. And still, they're some of the brightest sources of radio emission out there, even once they've traveled for 1 billion light-years through space. Now, FRBs can be one of two types: repeaters and one-offs, which indicate their nature. See, most common explanations for FRBs are based on cataclysmic events that happen in the vast space, such as a neutron star being swallowed by a black hole, a neutron star crashing into a white dwarf, or a supernova. However, these are usually sporadic FRBs, meaning they burst only once and then go silent forever. But if a fast radio burst occurs periodically, it's thought something out there controls these outbursts of radio emission. The great challenge when it comes to detecting FRBs is not only they are located billions of light years away, but they're also extremely short-lived. Even such mighty signals that release the same amount of energy our star does in 100 years are too fleeting for us to thoroughly examine. So it seems you need an extremely advanced mechanism to catch them, and that's exactly the problem that Project Breakthrough Listen can solve. It is by far the most ambitious project searching for intelligent life that's ever existed. The project consists of telescopes and other tools capable of detecting a laser with power equal to an ordinary household light bulb at a distance of 25 trillion miles. Scientists in Breakthrough Listen plan to study about 1 million stars, and even 100 nearby galaxies to detect any signals that could point to extraterrestrial civilizations. The hard part for the project's team is to identify so-called techno-signatures in a pile of countless radio waves caused by equipment on our planet, machines orbiting the Earth, and naturally occurring phenomena in space. So even with such powerful equipment, the Breakthrough Listen team has long struggled to find signals worthy of scientific attention. About 6 years had passed for them to finally come across something intriguing. When studying Proxima Centauri, Australia's Parkes Observatory collected about 25 hours of data, and as scientists took a profound look into this information, they stumbled on something strange. A wildly odd FRB signal occurred 5 times throughout that period. The object was named BLC-1, which stands for Breakthrough Listen Candidate 1. The signal is presumably coming from our neighboring star system, Alpha Centauri, and became the very first FRB that passed the project's filtering criteria, like disregarding signals with a constant frequency and those that are not fixed to a specific point in space. What caught astronomers' attention about BLC-1 was the signal's narrow bandwidth, with the frequency of 982.002 MHz, and the fact that it vanished as the telescope ever slightly changed its focus to another point in space. And to the best of our knowledge, such signals do not happen naturally. The only way to produce them is through human-built technology, like Wi-Fi, GPS, satellite, or cell phone towers. Another weird thing is that BLC-1 also demonstrated a slight drift in frequency. Now, such drifts or changes in frequency normally signify one of the two things. It's either because of the Earth's movement or a movement of an extraterrestrial source causing the signal. However, the drift is actually the opposite of what's expected. Instead of going down, it goes up. And when something that unpredictable happens in space, it usually leads to something intriguing. This positive drift could be a result of a transmitter on another planet or even a spacecraft that's accelerating in the direction of Earth at a consistent speed. Don't worry and exhale. Once astronomers compared the drift to the motion of the planets in Alpha Centauri, they did not find a single match. So there's also a chance BLC-1 could be reaching us from a tremendously distant place, somewhere beyond Alpha Centauri. And so while the signal may not come from our neighboring star, it doesn't seem to come from Earth either. So what's the true origin of BLC-1? So far, scientists cannot reach a consensus regarding this question. Some believe the radio emission is coming from some kind of technology that we put out there in space. Others speculate it could be an unknown natural occurrence. Still, the idea that the signal is a result of a specific device is the best simple explanation. And although the majority of theories are built around human interference, like nearby microwaves, cell phones, aircraft, and even satellites, there's a decent chance this was a postcard from another civilization, even if it's not a neighboring one. And if that's the case, the Milky Way is completely filled with intelligent communicating civilizations. Most of you probably wonder what would happen if we stopped guessing and just replied. What could be the consequence of such a decision? Well, if we assume that it was an attempt by another intelligent society to contact us, we should as well presume that since we both exist in a 10 billion-year-old galaxy, they've been there for long enough to develop such technologies. So a positive outcome would be human beings learning from our friends how to make it through millions of years in such a hostile place as space. If they could do it, our odds for success are high too. Now, it's clear why BLC-1 drew so much attention, virtually becoming a Hollywood star within the context of space science, and by doing so, it eclipsed other but not less exciting FRBs. One of them is a not-so-old signal detected by the novel radio telescope named Canadian Hydrogen Intensity Mapping Experiment. Astronomers have successfully tracked it back to a spiral galaxy some 500 light-years away. This one has got an unusual repeating cycle of about 16 days. During the first 4 days, it tends to be active, producing bursts on an hourly basis. Then comes the 12-day break period. All this only adds to the signal's uniqueness. The origin is not just unknown, but scientists cannot even make predictions as no existing explanation seems to fit. There is yet another fascinating FRB that the CHIME telescope revealed to us in 2020. Astronomers believe this FRB came from a globular cluster located close to a galaxy M81, one of the brightest out there. The weird thing about it is these sparkling clusters aren't known to have stars that can come from magnetars, so it's somewhat like spotting a smartphone embedded in Stonehenge. Astronomers and theorists had long been quite satisfied with magnetars as a common explanation for fast radio bursts, but FRB 2020-0120e has all the potential to become a game changer. FRBs don't seem to give up their secrets that easily. So there are two mysteries linked to FRB 2020-0120e, and scientists have to solve at least one. The first issue is how to understand the birth of magnetars in these clusters of aging stars. The second one, hardly less complicated, is to get a clue about how old stars can ever produce such powerful bursts of radio emission. Another staggering FRB, known as FRB 20428, came from a small and faint constellation Vulpecula. But while scientists got lucky finding a magnetar there, which points to the origin of the signal, they still rack their brains over the strange property of the signal. See, usually FRBs only carry radio waves, but this one brought a burst of X-rays with it, bringing scientists to a grinding halt. It's also 3,000 times brighter compared to all the other FRBs previously detected. So far, it seems, the more astronomers discover about fast radio bursts, the weirder these signals get. So why do scientists even bother to spend so much effort trying to get a clue about them? In some sense, these outbursts serve as camera flashes, shedding light upon the universe's evolution, the types of matter and its distribution in space. And once we know about these things in detail, we can become confident space explorers. So far, we've already discovered somewhere around 1,000 fast radio bursts, but just 15 of them were successfully located. So the majority of these signals haven't been studied yet. And even though we didn't find an alien techno signature yet, it doesn't mean we won't. It could just be a matter of several years until we finally discover a potentially existing interstellar communication network ready to host us.
pretty lies. Look me in the face, tell me that you love me.